Welcome to the Math Review. In this lesson, we're going over how to convert fractions to decimals. There are 3 steps in order to convert fractions to decimals, and step 1 is to divide the numerator by the denominator. In case you don't remember, the numerator is the top of the fraction and the denominator is the bottom of the fraction. Number 2. We're going to place a decimal point in the dividend and the quotient. I'll show you this specifically when we get to that step. And number 3, we need to annex zeros as needed. All that means is we're going to have to write zeros after the decimal point as much as we need to, until we either get a remainder of 0 or we notice a pattern that keeps going and going and going. Here's our first example. We've got 3 over 8. The first thing we need to do is set up our long division notation, which looks like this. The second thing we'll need to do is divide the numerator by the denominator. Now that we have our long division notation, we need to put our numbers in the right spot. Since we're dividing the numerator by the denominator, the numerator, the 3, will go inside the long division notation. And the 8, the denominator, will go outside the long division notation. Now that we have it set up, we'll notice right away that 8 cannot go into 3. So what we'll do is we'll write a 0 here, right on top of the 3, because 8 goes into 3 0 times. And this is when we get to step 2. We're going to place the decimal point in the dividend, which is here, inside the long division notation. So we'll put a decimal point here, and in the quotient right above it. So right above this decimal here in the dividend, we're going to put a decimal right above it in the quotient. And then we're going to annex as many zeros as we need. So I'll put a 0 here first. And then we'll try and find out how many times 8 can go into 30 without going over. And that would be 3. Because 3 times 8 is 24. We'll write that under the 30. We'll subtract. We'll have to borrow from the 3, so that becomes a 2. And the 0 will become a 10. 10 minus 4 is 6. And 2 minus 2 is 0. Since we still have a remainder, that means we're going to have to annex another 0. So we'll put a 0 here, and then bring it down. So now we're seeing how many times 8 can go into 60. And that would be 7. Because 8 times 7 is 56. I'll write that here. I'll subtract it. I've got to borrow from the 6, so the 6 becomes a 5, and the 0 becomes a 10. Now we've got 10 minus 6, which is 4, and 5 minus 5, which is 0. Since our remainder is not 0, it means we're not done, and we're going to have to annex another 0. Bring that one down as well. And now we're going to try and see how many times 8 can go into 40. And that happens 5 times. So I'll put a 5 up here above that last 0, because 5 times 8 is 40. I'll write that 40 here, subtract it, and I get 0. Which means the final answer is 375 thousandths. Although most students would read this as 0.375. So we would say 3/8 is equivalent to or equals 0.375. So here it is as a fraction, and here it is as a decimal. Let's try one more example. So in example 2, we've got 5 over 6. The first thing we'll do is set up our long division notation. Next, we'll make sure we put our numerator inside the long division notation, and we'll put our denominator outside the long division notation. And 6 goes into 5 0 times, so we can put a 0 right above the 5. And this will bring us to step 2, which is to place a decimal point in the dividend and quotient. So we'll put a decimal point right here after the 5 in our dividend, and directly above it in our quotient, which is just the answer for division. And next, we'll annex zeros as needed. So we'll put a 0 here, and then we can start dividing. How many times can 6 go into 50? Well, that would be 8. Because 8 times 6 is 48. When I subtract that, and I'm going to have to borrow, this 5 will become a 4. So this 0 will become a 10. 10 minus 8 is 2. And 4 minus 4 is 0. Since we have a remainder, it means we'll have to annex another 0. So we'll put a 0 right here and bring it down. So now we're going to do the same thing, but now we'll see how many times 6 can go into 20. And that would be 3 times. So we'll write 3 above the 0, because 3 times 6 is 18. So I'll write that here, put the subtraction symbol, and then when we subtract, we're gonna have to borrow. So this 2 will become a 1, and this 0 will become a 10. 10 minus 8 is 2, and 1 minus 1 is 0. Since we have a remainder, we're gonna need to annex another 0. So we'll put a 0 here, and then repeat the process. So we'll bring that 0 down. And now we'll see how many times 6 can go into 20. That sounds awfully familiar. We already did it once here. So now we're just doing it again, which is a strong sign that this is probably going to be a repeating decimal. So now I'll put 3 here again, because 3 times 6 is 18. I'll subtract this, but I'll have to borrow. This 2 will become a 1, this 0 will become a 10, 10 minus 8 is 2, and 1 minus 1 is 0. So we ended up getting a 2 here, a 2 here, a 2 here, so we're going to end up with the same value when we subtract, and we're going to end up with the same exact number to divide because we keep ending up with 20 by bringing down these zeros. Here we ended up dividing 20. Here we ended up dividing 20. And if we did it again, guess what? We'll put a 0 here, we'll bring it all the way down, and that's going to end up being another 20, which means it would just end up being another 3. And that pattern's going to keep going and going and going. That's what these 3 dots mean. So this is a repeating decimal. So we'll say 5 over 6 is equal to 0.83 repeating. And that's what that little bar above that 3 means. That means just the 3 repeats. So again, 5 over 6 is equal to 0.83 with a repeating 3. Thanks for watching. We'll see you next time on the Math Review.